Okay.
Hi everyone, good morning. Today we'll be doing the AMC 8 training. Um, and let's get started. So instead of like last time where we just revised the previous papers, today we'll be doing topic-wise. So the class agenda for today is that we'll be doing permutations, combinations, casework, complementary counting, probability, and geometric counting. You'll know what each of these topics are by the end of this class and how to use them too. So let's start with permutations and combinations. So by the end of this class, you will learn what are permutations, what are combinations, what's the difference between them, what is the formula for permutations, what's the formula for combinations, how you would use them in real life, and like actual problems from the AMC8. You'll also be getting some extra problems for homework. So, first of all, the definition of permutations is, well, you can use them to find the different ways to arrange a set of items in a specific order. And combinations, they're a selection of items from a larger set where you pick a smaller set and the order of selection does not matter. And here is a problem of permutations. So suppose that a class has 8 students, and 3 students will be receiving gold, silver, and bronze medals. And now they're asking us how many different outcomes are possible. So we have 8 students here. And now we need to choose 3 students and we need to give them gold, silver, and bronze. So we would do permutation. So 8 permutation 3. Meaning that the formula for this would be 8 factorial divided by 8 minus 3 factorial. And once again, this is the formula for permutations. And factorial just means like a number times a number minus 1 times n minus 2 times n minus 3 all the way until 1. Suppose that it would be 5 factorial. 5 factorial would be equal to 5 times 4 times 3 times 2 times 1. 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. So now we have 8 factorial, meaning that it would be 8 times 7 times 6 times 5 factorial, because 5 factorial is the same thing as 5 times 4 times 3 times 2 times 1. And the bottom one would be 5 factorial because 8 minus 3 is 5, and we have a factorial sign right there, so it would be 5 factorial. And in the top, we could have just wrote all like 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But instead, we chose to write it this way because we know that multiplication and division both cancel out with each other. So this 5 factorial on the bottom would be canceling out with this 5 factorial on the top. And so we will just be left with 8 times 7 times 6, which is equal to 56 times 6. 56 times 6, which would be equal to 336. And so our final answer would be 336. So once again, this would be permutations because in here, if you think about it, gold, silver, and bronze is not the same as bronze, silver, gold. They both are different. Just like first place, second place, and third place is different from third place, second place, and first place. So, in combinations, on the other hand, the order will not matter because you're picking some students. So it would be suppose that this would be a combinations problem. In how many ways can you choose 3 students out of 8 students to represent the class? You would do 8, choose 3, meaning that there's 8 students, and we will need to pick 3 out of them. So, and the order will not matter because the 3 students are the same. No matter which order you pick them, the group will still be the same. So it would be 8 factorial divided by 3 factorial times 8 minus 3 factorial. This is once again the formula for combinations. So on the top, it would be 8 factorial divided by 3 factorial times 8 minus 3 factorial, which is the same thing as 5 factorial. So we would do, here, I'll write it here because we don't have much space there, 8 factorial divided by, or instead of 8 factorial, we can do 8 times 7 times 6 times 5 factorial once again because there's a 5 factorial on the bottom. And then divided by 3 times 2 times 1, that's 3 factorial times 5 factorial. Once again, the 5 factorial on the top and the 5 factorial on the bottom would both cancel out with each other. And then we have the 3 times 2 times 1, which is the same thing as 6 times 1, which is just 6. So this would cancel out, and this would cancel out as well. And we will be left with 8 times 7, which is equal to 56. So our final answer would be equal to 56. So this is combination because there's no rows here. By rows, I mean first place, second place, third place. We're just trying to pick 3 students out of the 8 students. And the order does not matter again because once again, the groups will still be the same. So, another problem in permutations would be how many different ways are there to arrange 4 letters from the word numbers? So, in numbers, there are 7 letters here. So, we would do 7 permutation 4. So that would be 7 factorial divided by 7 minus 4 factorial. And that would be equal to 7 factorial divided by 3 factorial. So another way to write 7 factorial is 7 times 6 times 5 times 4 times 3 factorial. And we can just write 3 factorial on the bottom because once again we know that division and multiplication cancel out with each other. So the 3 factorial and the 3 factorial will be canceling out with each other, and we will be left with 7 times 6 times 5 times 4. And that would be equal to 42 times 20. And we got 42 times 20 because 7 times 6 is equal to 42, and 5 times 4 is equal to 20. So 42 times 20 is equal to 840. And that would be a final answer. Well, if that would be in permutations, but if it would be combinations, we can write this number as how many different. Yeah, someone has a question, you can unmute. Can you, yeah.
Read messages.
What? What did you say?
Someone has a question.
Oh. Why not 7 times? Oh, you're talking about permutations? So you said that why is it not 7 times 6 times 5 times 4 times 3 times 2 times 1? You could also write it, I'm assuming that you're talking about this part right over here. So you can also write it as 7 times 6 times 5 times 4 times 3 times 2 times 1. But anyways, we know that the 3 factorial on the top and the 3 factorial on the bottom will both cancel out with each other. So here, suppose that you write, let me just delete this part here. Okay, so you can also write 3 times 2 times 1. And here you can also write 3 times 2 times 1. But here, once again, this is just 3 factorial, and this is also 3 factorial. We got this from here, right here, so 3 factorial, right? So this number over here will also cancel out with this number over here. And so we can just, 3 factorial is just a simpler way to write this, but if you want, you could just write this like in like full form. You can try to write this too. But 3 factorial is just an easier way to write this down. So that was permutations, and now this is the same problem but in combinations. How many different ways are there to pick 4 letters from the word numbers? Here, we're trying to pick 4 letters. No, we're not trying to arrange the 4 letters. We're trying to pick them. So we would do 7C4, meaning 7 choose 4. And that would be equal to 7 factorial divided by 7 minus 4 factorial times 4 factorial. And this would be equal to 7 factorial divided by 3 factorial times 4 factorial, which is the same thing as 7 times 6 times 5 times 4 factorial. We can also write times 4 times 3 times 2 times 1. So I'll just write 4 factorial because it's just an easier way to write that. Times 4 factorial. Divided by 3 times 2 times 1 times 4 factorial. So the top and the bottom 4 factorial would both cancel out with each other. The 3 times 2 times 1 and the 6 would cancel out with each other, meaning that there's just 7 times 5, which is equal to 35. And so 35 would be our final answer. Does anyone have any questions on both of these problems that we just did? This one and this one? Okay, so if no one has any questions, then here are some tricks to know immediately if it's permutations or combinations. Sorry, someone has a wait, can you unmute? Do you have a question?
No.
Earlier
Okay.
did it. You said that we didn't do the times 4 factorial, and then you changed it again.
Oh.
That's why.
Oh, okay. So here are some tricks to know if it's permutations or combinations. Usually if it's permutations, it'll be like roles or position or ranks, or it will clearly say arrangements, such as for like the problem where you have to give 3 students gold, silver, and bronze. But for combinations, it's usually like groups, selections, teams, or it will say choose. So these are like these arrangements and choose, they're most likely pointed out. But once again, that this may not work for all of these problems. So I have some scenarios here, and if you know the answer to these, you can raise your hand or you can just unmute. So this is a question. Is this permutations or combinations? So there's going to be seating arrangements. Suppose that you and 4 friends are sitting in a row for a movie. How many different ways can you arrange the 5 of you? Does anyone know if this is permutations or combinations? Please raise your hand if you know the answer, or you can just say it in the chat. Okay, so yeah. Yeah, this is permutations. You are correct. This is permutations because it's saying arrange here, right? So if it says arrange, it'll say it'll most likely be permutations. So here, suppose that Alice, Bob, and Charlie, they're all sitting in a line for a movie. But that is different than Charlie, Bob, Alice, because the order matters in permutations. So another scenario is that suppose that there are 8 runners in a 100-meter race, but you want to know how many different results are possible for gold, silver, and bronze. Does anyone know the answer to this? This would be permutations, not combinations, because the order for gold, silver, bronze wouldn't matter. The order would matter because it's gold, silver, bronze is not the same as bronze, silver, gold. If they're just asking for like, suppose the top 3 or just choose 3 winners to win this race, then it would be combinations. But now they're asking for gold, silver, and bronze, meaning that it would be permutations. Once again, the order matters. So is this permutations or combinations? Suppose that a pizza place offers 9 toppings. How many different 3 toppings pizzas can you make? There is a pizza and they're asking to choose 3 toppings. Yes, this is combinations. All of you are correct. This is combinations because the order which you choose the toppings will not matter. It's just like you're gonna pick 3 toppings and you're gonna place them on your pizza. The order does not matter because the pizza won't change depending on the order you pick. Pineapples, olives, pepperoni, the order you pick them and you place them on the pizza, it's the same thing as olives, pepperoni, pineapple. So, does anyone have any questions on permutations or combinations? Okay. So if no one has any questions, then we'll move on to our next topic, which is casework. So, casework is basically considering all of the cases and adding them up. So this is a problem from the AMC 8 2002 paper. This is problem number 2. How many different combinations of $5 bills and $2 bills can be used to make a total of $17? And the order does not matter in this problem. So we need a total of $17 here. And they only have $5 bills and $2 bills. So we need to consider all of these cases and we just need to find all of the combinations. We just need to know how many different combinations are possible. So suppose that there's $17, right? So here we need to make $17. Suppose that there's only one $5 bill. So one $5 bill. And so it would be 17 minus 5. And there should be 12 left over, so $12. And for $12, we need to make $12 using only $2 bills. This is just one scenario which we can do, and we will be using 12 divided by 2, 6 $2 bills, so 6 $2 bills. This is one way. This is one scenario. But another case would be, suppose that we have 2 $5 bills. So 2 $5 bills. And that would be 17 minus 5 times 2. 5 times 2 is equal to 10. So 17 minus 10 is equal to 7. But now we need to make $7 out of only $2 bills. Is this possible? We would have to use 3.5 $2 bills. But we can't split a $2 bill in half. It's either a $2 bill, it's just either a one $2 bill or none $2 bills because we don't have any ones. So then this case is not possible. This case is not possible. Our third case would be using three $5 bills. 3 $5 bills. And so that would be 17 minus 3 times 5. 3 times 5 is equal to 15. So 17 minus 15 is equal to 2. And we can make a $2 bill with just one $2 bill. So this case would work. And if we have 4 $5 bills, then that would be 20. meaning that's more than 17. But we just need $17. We don't need any more than that. And so for this problem, we only have two possible cases. And so that would be our final answer choice too. Another example of casework is how many integers from 1 to 10 are multiples of 3? So we need to know the multiples from 1 to 10 of 3. So here are the multiples of 3. 3, 6, 9, 12, but 12 is already more than 10. So there's only 3 multiples of 3 from 1 to 10. And that would just be your final answer choice. Another example of casework is how many integers from 1 to 100 are divisible by 2 or 5? If a number has to be divisible by 2, it must be an even number. And if it has to be divisible by 5, it must end in a 0 or a 5. So, how many numbers from 1 to 100 are even or end with a 0 or a 5? So, there's always like half of it is even. So, half of the numbers from 1 to 100 are even, meaning that there's 50 numbers from 1 to 100 which are even. Well, how many integers from 1 to 100 are divisible by 5? That would just be 100 divided by 5, which is equal to 20. So there's 20 numbers that end with either a 0 or a 5. But now we have a problem here. The answer is just not 50 plus 20, which is equal to 70. Remember that there's multiples of both 2 and 5. And the least common multiple of 2 and 5 is 10. So that means that we need to cancel out all of the multiples of 10 from 1 to 100. And how many multiples of 10 are there from 1 to 100? There are 100 divided by 10, which is equal to 10. So there's 10 multiples of 10 from 1 to 100. So we would do 50 plus 20 minus 10. That would be equal to 70 minus 10, which is equal to 60. And so our final answer would be equal to 60. Does anyone have any questions on this problem? Okay, so here's another example of casework. How many integers from 1 to 100 are divisible by either 2 or 3? So once again, we know that based on this problem that there's 50 integers that are even. And so if it has to be divisible by 2, it has to be even. And so there's 50 numbers like that. By 3, on the other hand, how many integers from 1 to 100 are multiples of 3? This would be 100 divided by 3, which is equal to 33 approximately, without the remainder. So this is 33. But now we need to cancel out all of the multiples of 6. And we have to do 6 because 6 is the least common multiple of 2 and 3. And so how many multiples of 6 are there? It would be 100 divided by 6, which is equal to 16, remainder 4. But we don't really need the remainder, right? So there's just 16 numbers like that. So we would do 50 plus 33 minus 16. 83 minus 16 is equal to 67. And so that would be our final answer choice. Another example of casework is what is the sum of the solutions to this problem? So first we need to find the solution. We need to find the value of x, and then we need to add all of the sum together. So this sign right over here, it symbolizes absolute value. And the absolute value can never be a negative number because absolute value just means the distance from 0 to a point on a number line. So let me draw a number line right over here. Okay, so this can be a number line right up here. And suppose that this point is 0. And this is -5. And this is 5. So what is the distance from 5 to 0? That would just be 5. So you can from 0 to 5, there's 5 units. From 0 to -5, there's also 5 numbers between them. Or there's not 5 numbers, there's 5 points. So then the absolute value, the distance can never be negative. So here we can do x minus 3. I'm just removing the absolute value sign equals 5. And there's another case such as x minus 3 equals -5. Because maybe x can be a negative number. Right, so we have this. And to solve this, we would just do +3, +3, and we get x is equal to 8 for the first case. For the second case, however, we would get +3, +3. And we do +3 because we want to isolate x just by itself to get x equals some number such as this. So we get x equals -5 + 3, which is equal to -2. So we have two cases for this problem, x equals 8 and x equals -2. So they're asking what is the sum of the solutions to this problem? That would just be 8 plus -2, which is the same thing as 8 minus 2, which is equal to 6. And that would be our final answer. Another example of casework is, in how many ways can you make 10 cents using pennies, nickels, and dimes? So, suppose that you have just dimes. So you have just dimes, and we know that dimes are worth 10 cents, nickels are worth 5 cents, and pennies are worth 1 cent. So in how many ways can you make 10 cents? So with just dimes, you could just use 1 dime, so 1D. And this is one way. You could do, maybe you can use 2 nickels. 2 nickels, that's another way. Because we know that 2 times 5 is equal to 10. Or we can just use all pennies, maybe 10 pennies. And that would be case 3. Suppose that you have 1 nickel. If you have 1 nickel, that would be equal to 5 cents, right? But then how would you make the other 5 cents? You can use another nickel, but we already have this listed, 2 nickels. You can do 1 nickel and 5 pennies. That would also work. So 1 nickel and 5 pennies. That's our 4th way to do this. And so since there's 4 ways to do this, our answer would just be 4 ways. So does anyone have any questions on casework? Okay, so if no one has any questions, then we'll go on to complementary counting. Complementary counting and casework are both really similar, except in casework, you count what is needed, but in complementary counting, it's basically counting the opposite of what we want and then subtracting it from the total. This may look really confusing at starting, but we will take some examples. So, complementary counting. Suppose that you have 4 coins. And you're gonna toss them, and the coins have an equal chance, right? So if you toss them, they'll either be heads or tails. And how many ways will there be at least one head? So we have 4 coins here. 3, 4. First, what's the total possibilities? So we have 2 choices for the first one. 2. By 2 I mean heads or tails. And we will need to multiply this, and we will be getting 2 to the power 4, which is equal to 16. So there's 16. So 16 is just the total possibility. But now they're asking us, how many ways will there be at least one head? So what's the opposite of having at least one head? By at least they mean that there can also be all of the heads, 3 of the heads, 2 of the heads, 1 of the heads. But what's the opposite of all of that? It's 0 heads. So if it's 0 heads, how many possibilities are there to be at least 0 heads? Meaning that has to be all tails. It can be tails, tails, tail, tail. So there's 4 tails here. So this is one possibility. And this is the only possibility as well, because we can erase this and put a head. But here, this would make this statement over here true, because they're just asking at least one head. And so the opposite of that would be having all tails. So this is one way to do this. And since there's only one way to do this, it would just be 16 minus 1. And we have to subtract 1 because this right over here is the opposite of what we want. So 16 minus 1 is equal to 15, meaning that there's 15 ways there can be at least one head. So that's the first example, but for the second example, if you toss 4 coins, how many ways will there be at least 2 heads? It's basically like the same question, but just slightly different. So we still have the same possibility, same total, 2 times 2 times 2 times 2, which will be equal to 16. So there's still 16 possibilities. 16 is still the total. And now they're asking us how many ways will there be at least 2 heads. So at least 2 heads. So to find at least 2 heads, we already know that the opposite of this would be either having one head or no heads at all, which is the same thing as tails, 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 tails. And we already did this for the previous problem. So this would still be one chance. But now how many ways are there to have just only one tail, only one head? That would be 1, 2, 3, 4. That would be tails, 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 and we could have heads here. Okay, so maybe here. Or we can also do, maybe we can like switch some out. So we can do heads. Maybe we can do heads there. Okay? Or we can like switch spots again. And maybe we can maybe we can do this. Maybe. Okay, so we can keep switching the head out. Meaning that there's 4 ways for this one. And these two are the opposite of what we want. We either want 2 heads, 3 heads, or 4 heads. So since this is the opposite of what we want, there's 5 ways. And we would need to subtract that from the total, which is 16 minus 5, which is equal to 11. We can also use Casework to do this, just find the total possibilities of 2 heads, 3 heads, or 4 heads, but that will take a more longer way to do this. Casework is efficient for some other problems, and complementary counting you can use for some other problems as well. So an example of complementary counting is how many integers from 1 to 100 are not divisible by 3. First of all, we need to find how many integers from 1 to 100 are divisible by 3. And then we would need to subtract that from the total. Well, first, what's a total? The total is 100 numbers. There's a total of 100 numbers. So I'll just write total here. And how many of these integers are divisible by 3? That would just be 100 divided by 3, which is equal to 33 remainder 1, but we don't really care about the remainder. So let's just say 33. And now this is the opposite of what we want, because 33 of these numbers are divisible by 3. But what's the opposite of this? Or like how do you subtract it from the total? It will just be 100 minus 33, which is equal to 67. So there's 67 numbers from 1 to 100 which are not divisible by 3. And another example of complementary counting is how many integers from 1 to 100 are not divisible by 10. And for a number to be divisible by 10, it has to end either with a 0, or no, only 0. It has to only end with a 0. So how many integers from 1 to 100 are there? There's 100 integers. And how many of these numbers are divisible by 10? 10, 20, 30, 40, 50, 60, 70, 80, and 90, and 100. There's 10 numbers. And we also have to include 100 because they're asking from 1 to 100. So there's 10 numbers, and we would do 100 minus 10, which is equal to 90. So there's 90 integers from 1 to 100, which are not divisible by 10. And that would just be our final answer, 90. How many two-digit numbers do not have at least one digit equal to 7? This is basically the same problem here, except they're asking divisible by 10, but now they're asking how many two-digit numbers do not have at least one digit equal to 7. So how many of these two-digit numbers are there? So that would be from 10 to 100. Or sorry, not 100. That would actually be 99 because 100 is a three-digit number. So from 10 to 99, how many numbers are there? 10, 11, 12. We can also count them. We can also count all of them, but there would be 89 numbers. So 89. And how many of these numbers do not have at least one digit equal to 7? Well, first of all, how many two-digit numbers have at least one digit equal to 7? 17, 27, 37, 47, 57, 67, 77. We include 77 because they're asking just at least. 87 and 97. There's 9 numbers like this. So we would just do 89 minus 9, which is equal to 80. So there's 80 two-digit numbers which do not have at least one digit equal to 7. So does everyone understand what complementary counting is? Do you have any questions between the difference between them, casework and complementary counting? Okay. If anyone has any questions, then please raise your hand. So, yeah, you can unmute.
You forgot that the numbers that have 7 as the tens digit, like 71, 72, 73, 74.
Oh, okay. Sorry about that. I forgot those numbers. So, so there's 89 numbers, which will still be the same, which is still the total. And so let's just count this again. We have 17, 17, 27, 37, 47, 57, 67, 77, 87, and 97. There's 9 numbers like that, but then there's also 71 to 79. So we can't count 77 again. So there's 70, 71, 72, 73, 74, 75, 76, 78, and 79. So there's also 9 numbers like that. And so we would do 89 minus 9, and that would be equal to 80. But then we also have to do 80 minus 9, once again, because of like 70, 71, and so on, which is equal to 71. And so instead of 80 numbers, there's actually 71 numbers. And so our final answer would be equal to 71. So now let's go into probability. And what's probability? Well, probability is basically the likelihood of something happening. An example would be, suppose that a dice has numbers 1, 2, 3, 4, 5, 6, and you roll it once. What's the chance of it rolling a 6? So here, there's an equal probability for all of these numbers. And there's 6 numbers here. What's the probability that you'll get one of these numbers, which is preferably a 6? That would just be 1 over 6, since there's one number which you're trying to choose, and there's 6 numbers of the total. So the probability would just be 1 over 6. Suppose that a fair coin is tossed. What is the probability of it landing on a head? There's 2 sides of a coin, a head and a tail. So what is the probability of it landing on one specific side, which is a head? Since there's 2 sides, and we need it to land on one of the side, which is basically a head, the probability would just be 1 over 2. Suppose that a fair coin is tossed 3 times. What is the probability of it getting exactly 2 heads? So there's a fair coin and it's tossed 3 times. So 2 times 2 times 2. And this is the chance for every time. This is just like the total chance. So 2 times 2 times 2 is equal to 8. 2 to the power of 3. What is the probability of it getting exactly 2 heads? So we wanted to get just 2 heads. And they don't have to be consecutive. They can just be maybe like a head over here, head over here. Maybe there can be a head over here, head over here. So if we try to arrange this, there can be a head here, head here, head there, head here, head here, head here. So this is one possibility, 2 possibilities, and 3 possibilities. There's only 3 possibilities like this. So then the answer would just be 3 by 8. That would just be your final answer. Another example of probability is a standard deck has 52 cards, and one card is drawn at random. What is the probability that the card is a red face card? So there's 2 colors on a standard 52 deck of cards. There's either red and black, and they both have an equal possibility. They both have an equal number of cards. And there's 26 red face cards, and there's 26 black face cards. And what is the probability that we're going to pick a red face card out of the standard 52 cards? That would just be 26, which is the total red face cards, divided by just the total amount of cards, which is 26 by 52, which if we divide by 26 on both the numerator and the denominator, it would be 1 by 2, which would just be the final answer. Suppose that a standard deck of cards has 52 cards, and we need to pick one card, which is drawn at random. What is the probability that the card is a spade? So here in this picture, they're showing us what the spades are, like how many spades there are. And if we count them, there's 13 spades. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's these cards as well. Jack, Queen, King. So there's 13 cards. And what is the probability that the card is a spade? And there's 4 types of card. Spade, and there's another 3. But all of those 3 have an equal probability too. So that would still be 13, which is the total number of spades divided by the total number of cards in a standard deck, which is 13 over 52. If we divide by 13 on both sides, it will be 1 by 4. So there's a 1 by 4. There's a 25% chance that we will be drawing a spade. So a standard deck has 52 cards, and 1 card is drawn at random. What is the probability that the card is a 10? There's only 4 10s in the standard deck, so there's only 4 10s. And so we would just do the total 10s. We would just do the total number of 10s divided by the total number of cards, which is 4 by 52, which is equal to 1 by 13. And that would be our final answer. Suppose that a bag contains 5 red, 4 blue, and 3 green marbles, and 1 marble is chosen at random. What is the probability that the marble is not blue? It cannot be blue. First, what is the total number of marbles? That would simply be 5 plus 4 plus 3. Once again, this is the total number of marbles there are. And the top one would just be, what is the probability that is not blue? So it cannot be blue. Well, if it can't be blue, then what color does it have to be? Either red or green. So it can either be red or green. How many total red or green marbles are there? 5 plus 3, which is equal to 8 by 12. This is the total probability, but then we can simplify this fraction, and that would be simplified into 2 by 3, dividing by 4. On the numerator and the denominator, it would be 2 by 3, and that would be our final answer. Does anyone have any questions about probability? Okay, so if no one has any questions, then we'll go on to geometric counting. So, what is geometric counting? Well, geometric counting is basically counting the arrangements of objects in a geometric shape. By geometric shape, we mean like any shape, maybe circle, maybe triangle, maybe any like rectangle, square, any other shape. Here's an example. How many diagonals are there on a convex 10-sided polygon? First of all, convex just means that like maybe there can be no angles more than 180 degrees, and that like no angles also like leaning inward. Like suppose that can be like that. Okay, it can be something like that, okay? And no angle is like leaning inward. Like no angle is such like this angle is leaning inward. If we push it out, like we can try to make this angle also go like that. Right, so this is an example of this, and yeah. So there's a formula for this, and this is a formula. This is the total number of diagonals on an n-sided polygon. N just means like that sided polygon, like the largest number. So n would be, in this case, 10. So 10 times 10 minus 3 by 2, which is equal to 10 times 7 by 2, which is the same thing as 70 by 2, which is equal to 35. So that means that there's 35 diagonals on a convex 10-sided polygon. Here, in the next question, how many diagonals are there in a convex 100-sided polygon? We would simply just use the same formula as we did in the above problem, and that would be 100 times 100 minus 7 by 2. And this would be 100 times 97 by 2. Now, instead of solving 100 times 97 and then dividing the whole by 2, we could just do divide by 2 on the bottom, divide by 2 on the top, and we will be getting 50 times 97. And we can just solve this right over here. So 97 times 50 is equal to 4,850. And that would be our final answer. Yeah, if you have a question, you can unmute.
Why is it 100 minus 7?
Oh, you see this formula right over here? we're gonna use this formula to solve this question right over here, because they're asking how many diagonals are there on a convex 100-sided polygon. And so this is the same formula that we used here. We had 10-sided polygon, and so we did 10 minus 7. Or sorry, 10 minus 3 here, which is equal to 10 times 7. And here we're gonna do 100 minus 7. Or sorry, why do we do 7? Or sorry, yeah, this is 3 here. So 100 minus 3. I'm sorry if I wrote 100 minus 7. I think I meant 100 minus 3 here. So does anyone else have any questions here? Okay, so this is another similar problem to the above one, except they're asking how many rectangles of any size can be formed on a 4x5 grid. So we can make maybe a rectangle like this one. Okay, maybe we can, here, let me change the color. Maybe we can do something like this one here. Maybe we can do something like even bigger like this one. But we don't know like the size of the rectangle. It can literally be any rectangle. So then we need something for this as well. Well, to find the rectangle, we would need to find two horizontal lines and two vertical lines as well. We can make a rectangle like this one and this one. No matter the size, like this one can be one of the rectangles. It could also be like this big of a rectangle, and it's still a rectangle here. Just two horizontal lines and two vertical lines. We can make this one right over here. So what I'm just trying to say is that we can make a rectangle by just choosing two horizontal lines and just two vertical lines. So suppose that we have this line right here. So how many vertical lines and how many horizontal lines are there here on a 4x5 grid? 1, 2, 3, 4, 5. So there's 5 horizontal lines. And we would need to choose 2 of them, right? We would need to choose 2 of them to make the horizontal part of the rectangle. And we would need to choose 2 of them because we would need the top part and the bottom part. So we need 2. So 5 choose 2 times how many vertical lines are there? 1, 2, 3, 4, 5, 6. There's 6 vertical lines. So 5 choose 2 times 6 choose 2. Once again, we will need to choose 2 of the vertical lines to make the vertical part of the rectangle. So 5 choose 2 times 6 choose 2 is equal to 5. I'll write this on the bottom. Equal to 5 factorial divided by 2 factorial times 5 minus 2 factorial. Okay? And we'll just do 5 choose 2 first, and we can do 6 choose 2 later. So 5 factorial is 5 times 4 times 3 factorial divided by 2 factorial. Or I'll just write 2 times 1 times 3 factorial. Because 5 minus 2 factorial is the same thing as 3 factorial. The 3 factorial on the top and 3 factorial on the bottom will both cancel out with each other, and the 2 on the bottom and 4 divided by 2 is equal to 2. So it'll be 5 times 2, which is equal to 10. So the answer for 5 choose 2 is equal to 10. The answer for 6 choose 2, we would just do 6 factorial divided by 2 factorial times 6 minus 2 factorial. which is equal to 6 times 5 times 4 factorial divided by 2 factorial times 4 factorial. The 4 factorial on the top and the 4 factorial on the bottom will both cancel with each other, and we will be getting 2 factorial on the bottom. But 2 factorial is just equal to 2, so then this 2 and this 6, so it'll be 3. So it'll be 3 times 5, which is equal to 15. And all we have to do is that we have to multiply 5 choose 2, which is equal to 10, times 6 choose 2, which is equal to 15. So 10 times 15 is equal to 150. Therefore, there's 150 rectangles of all sides which can be formed on a 4x5 grid. If we try to draw all of the 150 rectangles on this 4x5 grid, we would most likely mess up. So then this is just a simpler way to find all of the rectangles here. So I have a question here. Yeah, you can ask your question first.
I just wanted to see the last formula 15 times.
This one?
Okay, yeah, that's all I needed to see. Thank
Yeah,
you.
okay. Okay. So does anyone else have any questions on this problem? Okay, so if no one has any questions, then if you want, you can try solving this problem on your own. I'll give you 2 minutes to solve this problem. And if you have the answer, then you can type it in the chat. After 2 minutes, we can check this answer together. Okay, so someone submitted their answer, and we can check the answer right now. So the question is, how many rectangles of any size can be formed in a 6x7 grid? First, we need to count how many horizontal lines are there. So 1, 2, 3, 4, 5, 6, 7. So there's 7 horizontal lines, and so we would be doing 7C2 because we will need to pick 2 of the horizontal lines from the 7, which will be equal to, I'm sorry, we'll solve that later. Well, how many vertical lines are there? There's 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 vertical lines. So we would do 7 choose 2 times 8 choose 2. So we would just have to find what 7 choose 2 is, and then we would have to find what 8 choose 2 is, and then we would just have to multiply both of them together. So 7 choose 2 is equal to 7 factorial divided by 2 factorial times 7 minus 7 minus 2 factorial. That would be equal to 7 factorial by 2 factorial times 5 factorial. So another way to write 7 factorial is 7 times 6 times 5 factorial. So the 5 factorial on the top and the 5 factorial on the bottom will both be canceling out with each other. And we know that the value of 2 factorials is equal to 2. So this 2 and the 6 divided by 2 is equal to 3. And so the value of 7 chooses 2 is equal to 7 times 3, which is equal to 21. So we need to find the value of 8 choose 2. 8 choose 2 is equal to 8 factorial divided by 2 factorial times, 8 factorial divided by 2 factorial times 8 minus 2 factorial. This would be equal to 8 times 7 times 6 factorial divided by 2 times 1, which is just 2 factorial, 2 times 1 times 6 factorial. The 6 factorial on the bottom and the 6 factorial on the top will both be canceled out with each other, and we'll be left with 2 times 1 divided by 8, and this 2 times 1 and this 8 on the top, so it'll be 4 times 7, which is equal to 28. And now we would have to do 21 times 28. And let me solve this right over here. I'll solve it on the top because there's not much space on the bottom. So we'll do 21 times 28. 21 times 28, which will be 8 here. I got 588. Yeah, I got 588. So I'm pretty sure that 588 is the answer. So if no one has any questions on this problem, anyone have any questions? Okay, so if no one has any questions, then we'll go on to this problem right over here. It's a similar problem, except they're asking how many squares of all sizes can be formed on a 4x4 grid of points. So there's a 4x4 grid over here. And now instead of trying to find all the horizontal lines and the vertical lines, we know that a square, see this shape right over here? This shape over here. This shape over here, it's not a square. It's a rectangle. But this shape right over here, it's close enough to a square. Okay, so here, we need to find how many ways that can we fit these shapes. So there can be, here let me change the color sign. I'll use blue. So there can be this square right over here. So there's a 1x1 square, and this is a 1x1 square. There can also be a 2x2 square, 3x3 square, and a 4x4 square. But how many of these are possible? First of all, for the 1x1 square, there's 16. If we count them, it's just 4x4, but there's also 16 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16. There's 16. Sorry, 16. 1 by 1 squares. 16 1 by 1. How many 2 by 2s are there? 2 by 2. Well, to find out how many 2 by 2s there are, suppose that there is 1. So there's 1 2 by 2. Okay, so 2 by 2. There's 1 here, 1 here, 2. Sorry, I'll just draw a close enough perfect one, maybe. So 1 here, 1, 2, 3, 4, 5, 6, 7, 1. Sorry, I think that this is easier to, so this is 1, 2, 3, 4, 5, 6, 7, 6, 7, and 8. And there's also a ninth one, there's also a ninth one right in the middle, like just the very center here. So I'll just highlight it using pink here. So there's also a ninth one right over here. So 9. So there's 9 2 by 2s. There's 9 of these. Okay, so how many 3 by 3s are there? So 3 by 3. Let me just erase these. Sorry, it's not erasing. Okay. So for 3 by 3s, let me draw a 3 by 3. So this can be a 3 by 3 here. So 3 by 3. There's 1 3 by 3, 2, 3, and 4. Let me do it again. 1. Look at the positions. 1, 2, 3, and 4. So there's 4 different positions. Therefore, that there's 4 3 by 3s. For 4 by 4, there's just 1 because we can't 4 by 4. There's just 1. This is a 4 by 4. No matter how many different ways we try to arrange it, there's just going to be 1 because this is just a 4 by 4 grid. So there's just going to be 1. So if we add all of these up, we're going to be getting 16 plus 9, which is equal to 25. 25 plus 4 is equal to 29. 29 plus 1 is equal to 30. Therefore, our final answer would be equal to 30. So do you want to try this question on your own? This is a 7 by 7 grid. I'll give you 2 minutes to solve this problem, and yeah, you can type your answer in the chat if you know the answer. I'll give you 2 minutes. I'll also show you an easier trick to do this problem. Okay, so I'll start by showing the trick and then we can try to solve this problem. So look here. In this problem, see that this is a 4 by 4 grid. 4 times 4 is equal to 16. So that means that there's 16 1 by 1 squares. So there's 16 here. Well, for 2 by 2, 3 square is equal to 9. So then there's 9 here. So there's 9 squares here. For 3 by 3, there's 2. 2 times 2, which is equal to 4. 2 squares is equal to 4. For 4 by 4, there's 1 times 1. 1 square is equal to 1. So then this would be the opposite way. So instead of doing 4 by 4, which is equal to 16, we're doing 1 by 1. So this may look confusing, but I'll explain this. Yeah, I'll explain this. So see, this is a 1 by 1 here. So 1 by 1 is just 4 times 4 square, and that would be 16. 2 by 2 is 3 squared, and we go down from 4, 3, 2, 1. This is 2 squared, and this is 1 square. Once again, this may look confusing, but I'll explain this in this problem here. So here we have a 7 by 7 grid. So if it would be 7, we'll just start off with 1 by 1. So 1 by 1, 2 by 2, 3 by 3, 4 by 4, 5 by 5, there's 6 by 6, and 7 by 7. So we have this right here. So if you look here, this is a 1 by 1. 1 by 1, we know that there's going to be 7 square number of 1 by 1s here. An example would be this is 7 by 7 square, so this is 7 by 7. Therefore, there's 49 squares here. This one makes sense here. 2 by 2, it would be 6 squared, which is equal to 36. 3 by 3 is 5 squared. We're just going down 7, 6, 5, 4, 3, 2, 1, which is equal to 25. 4 by 4 is just equal to 4 squared, which is equal to 16. 5 by 5 is equal to 3 squared, which is equal to 9. So there's 9 5 by 5s here. 6 by 6, there's going to be 4 because it's 2 squared. And 7 by 7, it's going to be equal to 1 squared, which is equal to 1. And once again, if you want to prove it, we can start off with 7 by 7. There's only one 7 by 7 here. So one 7 by 7 here. Sorry, let me just make this bigger. So there's only one 7 by 7 here. For 6 by 6, they're saying that there's 4. If there's 4 here, if there's 4, okay, so if there's 4, this is 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So this square over here, the square in blue, this is a 6 by 6. Now here, according to this one, they're saying that there's 4, but we just need to double check it. So this is one place to position it. This can be another place to position it. There's 2 so far. 3rd place and 4th place. So there's actually 4 places to position this. So let me just show it again. So 1, 2, 3, and 4. So we just proved why we can use this, and this is really also accurate. instead of like counting each square and trying to position it, it's also really accurate. But now we're not done with this question yet because we're asking how many squares can fit. So all we need to do is just add all of these together. So 49 plus 36 is equal to 85 is equal to 85 plus 25 is equal to 110 plus 16 is equal to 130. Wait, no, it's not equal to 130, sorry, it's equal to 126. Plus 9 is equal to 135. Plus 4 is equal to 139. And plus 1 is equal to 140. Therefore, our final answer is 140. And those of you who said 140, good job, your answer is correct. So does anyone have any questions about geometric counting or about anything we talked about in class so far? Please raise your hand or unmute, or you can type your question in the chat if you want. Okay, so if no one has any questions, then I also made a whole homework, and there's going to be 4 problems per each topic, meaning that since there's 6 topics, there's going to be 4 times there's going to be 4 times 6, which is going to be equal to 24 problems. So there's 24 homework problems. So this is for permutations, this is for combinations, this is for casework, this is for complementary counting, for probability. This is for geometric counting. For geometric counting, I also included probability here, probability. So, and plus all of these topics, all these problems in the homework also include some parts from each of the different topics that we talked about. And that's all for class today. And